Hello, and welcome to another episode of Hacking with Friends. I have my friend and computer science student Tim with me again, and today we're going to get into some fun stuff with Bettercap, where we bring back the 2005 Cat Fancy webpage by doing some DNS spoofing. Tim, are you ready for this?
I'm ready. Let's do it.
How do you feel about the fact that right now, if you go to catfancy.com, it currently resolves to absolutely nothing?
I am outraged by it.
I am too. And today we're going to take action. We're going to use our hacker powers to make sure that the good citizens of this Wi-Fi network have access to the 2005 version of the Cat Fancy homepage, because we feel like it's our responsibility to serve that page.
Our duty.
Of course, our duty. Mm-hmm. But if we were malicious, we could always just replace the Cat Fancy website with pretty much any website you're trying to log into and serve today's version of it with a little bit of phishing thrown in to capture your password. So while we're going to be serving up Cat Fancy today, we're actually doing this as an example of how an attacker could do this on any network they have access to. Now, that means if you have a shared living situation and you guys all share the same Wi-Fi network, if you have a weak Wi-Fi password and someone has broken into it, if you have an open Wi-Fi network and anybody can join, that means that anybody on your Wi-Fi network that knows the password or can get in can basically run any of these attacks we're demonstrating today and can go a lot further in terms of actually seeing what you're doing on the internet and then feeding you sites that might be trying to steal your passwords. Sound spooky?
Sounds very spooky. Also, you'd have to have a really sucky roommate in order for that to happen.
Yes, they're out there, trust me. So today, in order to follow along with this, we'll need to be able to put our card into monitor mode. And some of what we're doing is going to be a little bit sophisticated, but I'll try to walk everyone through it as best we can. If you're looking for a wireless network adapter that supports monitor mode, my computer happens to support it internally by default. It just has a built-in one that's Kali Linux supported, but you can always pick up a wireless network adapter like this one from Alpha Wireless, which is meant for boats.
Do you need me to hold this side?
Probably. Yeah, it's huge. So, of course, you don't need to get one this big. You can also go with the smaller one from somewhere like Panda Wireless or something like that. But I really like Alpha because they have really good gear and a lot of their stuff, it just works right out of the box. All right, so what we're going to be doing with this wireless network adapter is joining a network, sniffing the traffic, and then doing some things like reconfiguring the internal structure of the network so that we're able to basically place ourselves at the exact middle. Now, we're actually going to be doing two types of spoofing here, and one enables the other. First, we're going to be doing ARP spoofing, which means we're going to be abusing the address resolution protocol to constantly shout out on the network and say, hey, I'm the router, you should send packets to me first, and I will be the one that delivers them where they need to go.
Sounds fun.
Yeah, so once we basically join the network and then configure ourselves to be the new router, we'll forward packets that we want to onto the real router and then forward the response back to the person who requested it. So basically, we're turning our computer into a man-in-the-middle attack device by simulating a router and then sending all the traffic to the real router for it to do the work and then send us back the results. So that gives us the ability to intercept things like DNS requests, which is really what we want to do with this attack. Now, currently, if you go to catfancy.com, it should resolve to nothing. But if you're on our network, it should resolve to a web page that looks like the 2005 version of Cat Fancy. And the reason for that is because on our network, my computer is intercepting all DNS requests before they even hit the router and making the determination as to whether or not they even want to forward that request to the router at all. If not, then the web page just can't be loaded. But if I choose to instead send back my own result, then what that means is that the person requesting catfancy.com instead will be served a local version of the website that I have complete control over. Sound fun?
Yeah, sounds really fun.
So if you have a tiny bit of web development experience, or if you can just copy a website, you can pop up your own fake website on a network just by taking control of the address resolution protocol and doing an ARP spoofing attack.
I have to ask, did you save Cat Fancy for 2005 or did you use like the WayBackMachine?
I used the WayBackMachine.
Okay.
Although I do have physical copies of Cat Fancy starting in 2007 to 2012, I'm incredibly proud of.
All right.
Print copies.
Oh, okay, gotcha.
Yeah. So anyway, what we're going to do is dive into Bettercap. And first, I'm going to take a look at the effect on the network and what it looks like to actually have this attack running. And then we're going to work backwards and have Tim be able to set up the same attack, which hopefully will work.
So I haven't done this before, so we'll see how it goes.
Yeah, so I love Bettercap because it is super easy to basically take full advantage of being into a Wi-Fi network, having the password and being able to snoop around a bit. So let's go ahead and dive into my screen and we'll take a look at what a Bettercap attack looks like and the effect it has on the network. So here you can see I have 3 windows open, and the top window is running Bettercap. Now the one down here that's serving an HTTP server is actually serving up what I want to show. So if I wanted to quickly take a look at that, I'm going to go to a browser window, which is probably looking up how to change my screen resolution, and go to catfancy.com. And right now, it looks like it can't resolve it. So that means that there is no real cat fancy, and we're not able to intercept that. So well, for one, I'm going to make sure I'm connected to the right network. Yes, I am. And in order for me to see what the payload's going to look like, let me first do ifconfig grep inet. So I'm going to copy this right here and just run it in a browser window to make sure that our payload is there. Cool. All right, our payload is currently being served. Now let's switch on over to Tim's screen. And Tim, if you could go to a browser window and try to go to catfancy.com.
Sure.
Hopefully it'll work. If not, then we'll get it working. Boom.
Hey.
All right, so Tim is being served the Cat Fancy payload. And how is this working? You can see that from my computer, I wasn't able to resolve Cat Fancy because, well, it's not there. But what I was able to do was just take an old version of Cat Fancy, which obviously is in its, I would say, the golden years of Cat Fancy. And we can have access to all these great things to do with cats, all because we're spoofing a bunch of DNS requests and serving up Tim fictitious content.
I really love some of these titles. Just hold me, learn the art of doing nothing, ... with your cat.
It's the best. So I'm going to press Control-C. I'm going to shut it down, and Tim, go ahead and refresh. See what happens. I dare you.
It's not even done loading, technically.
Boom. Cool. So as you can see, suddenly this beautiful content has been yanked offline. What happened?
It's a crime.
I know. Well, it's because we stopped doing our part. We stopped serving up Cat Fancy to the world. But we're going to get into the guts of how this was working, and I'm going to stop also this attack so that everybody else on this network is able to resolve websites normally. So I'm going to press Control-C, quit the session, and if we can go back to my screen, you can see that the last thing that Bettercap did was restore the ARP cache of all 256 possible IP addresses on the network. So what this is usually doing is shouting constantly to every possible IP address on the network saying, hey, I am the router, you should send traffic to me. Now I've also stopped a simple Python HTTP server that I was using to serve the copy of the page. So really all I need aside from that is my IP address on the network to make sure I'm serving up, to make sure I know where I'm serving up all the information. And I can start basically meeting anyone's DNS request with my own custom example. So Tim, let's jump over to your screen and go ahead and stop running Bettercap, and we'll take this from scratch. Now you're running Ubuntu, right? Mm-hmm. Cool. So if you're not running Kali Linux, which has Bettercap installed by default, then Tim, can you tell me what trials you had to go through in order to get this installed?
Okay, it wasn't terribly hard, but you basically have to clone the GitHub repository. And then after I did that, I had to create it just downloaded the repo. So if I wanted to run it, I'd have to navigate to the folder, and then I'd have to run the Bettercap with a /. So in order to get it to work with just the Bettercap command, I created an alias in my .bashrc file.
All right, can you show, just as a quick example of what that looks like, just down first the GitHub repository and then what you did to get it running? You don't have to do the final command to install it, just for anybody who wants to follow along with it.
Yeah, so I literally just install, here we go. They have it on their website for...
Oh yeah, so if you need help, check out Bettercap's bettercap.org. They have really good documentation, and that's how we installed all this.
So I use this method.
The Linux deploy method.
The Linux deploy method. So it had me install Linux deploy and then use the go get to download the GitHub repository.
I see. So basically you use the Go package manager.
Mm-hmm.
Okay.
Yeah.
So by installing Linux deploy, then you can just go ahead and use Go, which is the language, I think, is Bettercap written in Go?
I don't think so.
Okay. Well, either way, you can use the Go package manager to install it then.
Mm-hmm. And then, does everyone on here know how to do aliases in their .bashrc?
No, could you show us how
Sure.
to do that? Because it's a little annoying for people who don't know.
Yeah, so I just did gedit, which is just a file editing software, and then .bashrc. And then if we go down to this section that I created called custom aliases, I just did alias Bettercap equals, and then the path of what it was done with.
Bettercap.
Yeah. So anytime I type in Bettercap, it'll just automatically basically have this whole thing filled in.
Oh, okay, cool. So if you're not getting the same easy experience as Tim was having just typing in Bettercap and getting it to work, you should try first following the instructions for Linux deploy on the bettercap.org website, and then creating an alias so you can just run it by typing Bettercap.
Mm-hmm. And also as a side note, if you want to run it as sudo, apparently you also have to do this alias, which is sudo equals sudo space.
Beautiful. That's beautiful. Okay. All right. Well, that's weird, but thanks Ubuntu for giving us that extra step.
But it works.
So do you need to, okay, cool. So you can also check out the help command and then the man, does it have a man page?
Let's see.
Nope. Okay, so just a help command. So most of these commands are documented really well on the website, but let's go ahead and fire up Bettercap as root, and let's see what we can do.
All right.
Cool. So go ahead and type help.
Help.
So there's lots of stuff here. We can do Wi-Fi sniffing. We can do, we can do ARP spoofing. We can do Bluetooth stuff. We can do DHCP6 spoofing. But that's not what we're going to do.
GPS?
Yeah. Oh, yeah. You can log everything with the GPS.
Wait, human interface devices? Oh, wow. Okay, cool.
No, there's tons of stuff that Bettercap can do, which is why I like it so much. So what we're going to do is first start net.sniff, and also go ahead and type help net.sniff. It might be net.sniff.help, but we'll find out soon enough. Oh, there we go. Okay. So this will give you all the information about this module, how to use it, and examples on how to use it. So scroll to the top. Okay, print sniffer session and statistics, start network sniffer in the background. So that's the command we want. We want net.sniff on, and also we can do net.fuzz on if you want to, but it might need some extra parameters.
Fuzzing for every, what's fuzzing?
Fuzzing is where you send a bunch of random input and like see if it has any effect on it. Let's just do the net.sniff on because we're doing reconnaissance right now.
All right, net.sniff on.
Cool. So now type net.show to get a table of all the different devices we've so far detected on the network. And maybe you should make this font a tiny bit smaller.
I think so.
You can just do Control.
Oh, right.
Cool. Yeah, we've got some long names. So we can see the manufacturer on one side, or the vendor on one side. Yeah. So we can see the vendor on one side. We can see the IP address. We can see the MAC address.
Sorry about that.
No, the information scrolls quickly. And we can, because we can see the name of the device, we can identify the gateway and some other things pretty quickly and be like, okay, like this is the router. This is Tim's computer. This is, well, I can't say that one, but that's a local administrator. And that's a Raspberry Pi. Like, okay, like that gives us our first clue on what's what. And then the vendor, obviously we can see the Raspberry Pi Foundation, Intel, Apple, Dell. All of this stuff is something that we're interested in because, my Windows virtual machine is associated. That's funny, I didn't know that. Okay, well, I hate that, but okay. So what we're going to do next is we're going to start targeting all these devices.
What does it say Dell and then the vendor is Apple?
That's me. And I do that to be annoying.
Oh, okay.
I basically just name all of my Apple devices various PC builds, and then I name all of my PCs MacBook.
Just
to be confusing on the network, because like you're just like, which one is wrong? But I can spoof a MAC address too. I've done that also to make it look like a very alarming computer on the network because the vendor names here are automatically looked up. So if you wanted to just change your
by the MAC address, gotcha.
Yep. So if you wanted to change yours to look like a Lockheed Martin's tactical network system, which is a very scary vendor lookup, that's probably my favorite thing to set like any random like computer I have to, because if you see that on your network, you're like, who did I upset that Lockheed is on my personal Wi-Fi network? So lots of fun you can have with that if you want to spoof it. Just keep in mind, anybody can spoof these. So obviously, setting my Apple computer to a Dell network name doesn't mean it's a Dell. And having the vendor come up as Apple doesn't actually necessarily mean it's an Apple, because if someone really wants to, they can change all this stuff. And I do, and it's fun. Cool. So now go ahead and type help again.
A bunch of other stuff came crashing down. Help.
All right, so you can see not everything is running. Go ahead and try net.probe on. So now we're going to switch and go active, and we're actually going to start probing devices on the network and see if we can turn over some more devices we might have missed on our first pass. And we can see we found another endpoint. So that's cool, and possibly another one.
This one is my current laptop.
Ooh, cool. So now type net.show, and we should maybe see some new results. Cool, yeah, it's bigger, so there's more. I guess there's something came in there. So we were able to identify some more devices by basically fully kicking on all of the different recon modules that we have for the network. So what we want to do next is actually start intercepting requests instead of individually just looking at devices on the network.
It has to be this small the font has to be this small to see the table.
I know. I'm sorry, guys.
So for your own sake, you can create this font small, but for our sake, we want to make it larger, but it's going to mess up the formatting.
Yeah, sorry. Okay, so we've identified devices on the network. Cool. What do we want to do next? Well, we want to be able to start digging into the traffic, and that requires us to do two things. One, we are not connected. Oh, you are connected via Ethernet. Oh, well, hello. Okay, never mind. So if you're connected via Wi-Fi, we first have to kick people off the Wi-Fi network, intercept their handshake, and know the password in order to start seeing what the communication is between them. So in order to make this happen, what we generally have to do is first type help, and then do you press enter, and then do you see the Wi-Fi? Type help Wi-Fi. Maybe it's Wi-Fi help. No, cool. So you can see here we can do deauthentication attacks. And what that means is we can briefly kick someone off so that they start a new session. And once we observe the session key, we can actually start digging into what they're doing. So that's really cool because it means we can observe more of the contents of the communication, like DNS requests or HTTP requests. Because unless we do this first, then we're not able to see the communication of any device that's been continuously connected before we started observing. So right now, even though we know the password, I can't see what you're doing until I kick you off for a second. You renegotiate the new key while I'm sitting here watching you, and then me knowing that key plus me knowing the password means I can decode your information, or I can decode your DNS requests and stuff like that.
Very sneaky.
Very sneaky. Okay, so let's go ahead and type help again. Since we're on Ethernet, we don't need to worry about that. And we're going to do the ARP spoofing. So type help arp.spoof. So not a lot of variety here. We can turn it on. We can also ban. So banning is nasty. It basically means we're not forwarding the packets anymore and we're dropping them instead. So I've done demonstrations. One of my first cybersecurity demonstrations was at a music venue that I worked for that will go completely unnamed. And yeah, so this venue asked us to assess whether or not giving out the Wi-Fi password was an issue. And in doing so, I did some ARP spoofing and then basically stopped forwarding the packets. And what they found out was that none of the credit card machines would process if the request couldn't get through. They're like, oh, it's not a problem because the credit card machines are encrypted. Well, it turns out it doesn't matter if they're encrypted if packets never get through. So for a business that relies on a network that's connected to a Wi-Fi network, what they didn't realize is that any person on the Wi-Fi could basically start doing ARP spoofing, reconfigure the network so that they're at the center of it, and then just drop the requests and not forward them onto the router at all. And what that means is that if you are highly dependent on that for maybe a camera feed or credit cards processing for an extremely high volume bar during a sold out show, you could start losing thousands of dollars per minute, it turns out, if you're not able to process orders very quickly or at all on a network that's shared. So that's why letting someone onto your Wi-Fi network actually can affect all of your Ethernet devices as well. And that's something this business didn't understand until the demonstration made it painfully clear. So if you have critical infrastructure, if you have payment credit card processing devices on a network that's also in any way connected to Wi-Fi, even though those devices might be on Ethernet, it doesn't mean they're on a separate network. We can still touch them with Bettercap, and in fact, it's even easier. So just keep that in mind. All right, so what we're going to do is turn on ARP spoofing. So go ahead and type arp.spoof on. Great. Now we've started basically sending out packets to everyone, telling them that, hey, I am now basically the router. So anytime someone sends out any information, they're going to basically get met with a blast of packets saying, hey, the router's right here. You should send all these packets to me. So I'm curious on my screen. While you're doing that, I'm just gonna see if I can detect any of those ARP packets. Yes, okay, can we switch over to my screen? So here we can see that this network is being blasted by ARP resolution messages. So if I click on one, I can see that these messages are quite simple. They say the sender MAC address is this, the target IP address is this. It's just inquiring, hey, who's at this IP address? The target MAC address is basically just all zeros. So it's just set to nothing. And then the target IP address is 192.168.254.134. So basically we're conducting a scan. This IP address is conducting a scan or resolving to a particular network. So this actually looks like a scan. It's sending out, here, actually, let me see. So what I like about Wireshark is it can give you some context about these messages. And I'm curious if just the fact that my screen is so short is why I'm not seeing that. Yeah, here it is. Okay, it's just this terrible resolution. Cool. So this is basically the contents of the messages. And I think this is a really cool way of showing this. Let me see if I can just do ARP. Cool. So with the simple filter, we can see that the message here, if we go, where did it go? Oh yeah, is basically who has 192.168.254.215. Tell this one. So this IP address is going crazy and basically requesting information about who's on the network. And as soon as it finds someone, then it does a slightly different exchange. Where's one here? It says 192.168.250 blah, blah, blah is at this MAC address. And it's like, cool. Now I know that there's a host here. I know there's a target. So our net.probe command is actually one of the things that's sending out all these ARP packets. So it's constantly going out and saying, hey, who has this IP address? Tell me. Hey, who is this one? Tell me. And if any device is there listening, it should respond and say, hey, I am, here we go, here's one. 192.168 blah, 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 254 is at this MAC address. So now I'm aware of everything I need in order to send packets or intercept things that are coming for this. I basically have the IP address and the MAC address, so I can uniquely identify, let's say, your computer on the network and start spoofing it uniquely if that's what I wanted to do. So lots and lots of packets are going out, but basically we should now be spoofing that we are the router and that this is something that your computer is where we should go in order to basically do anything.
So is everyone on the network, are all the packets on the network getting sent through my computer?
Possibly. Let's try it. So if I look up something like, let's go ahead and switch to your screen. It looks like, oh, well, okay, that website doesn't go anywhere, but I was hoping that we would see some traffic. You go to,
yeah, I see you went to Google, right?
Yep, that's true. I'm now at the Python website. Oh, I can also do, oh, well, that's over HTTPS. Let's do URL contains.
Oh, whoa! What happened? What's all this stuff?
It's a let's encrypt. Oh, you intercepted an HTTPS request from me, and you were able to capture the SSL information.
I don't know what that means.
Secure socket layer. So you were basically I connected to an encrypted website, but you basically were able to see the unique encryption key of that website, even though you couldn't see the contents of the communication.
Oh, let's see. Yeah, I see you went to Python. I didn't see it at first because my font size was making things on 2 lines, but I see you went to python.org.
This is true. Yeah, that's where it was. So I'm going to try to go to...
And then you went to Spotify, or someone went to Spotify. This might not have been you. It might have been someone
I
else.
think it might have been someone else. I'm going to try to go to another... I keep trying to go to websites that I think won't have HTTPS, but I keep being tricked. I need to do... Oh, I think I found one. Can you see anything?
Well, a lot of stuff happened. You went to calendar.
Can you tell what website I'm on? Well, it's just calling that... Oh, there. That's it. Right there.
Somerset schools?
Yeah, I just found some random middle school that doesn't use HTTPS. But here's just an example.
Okay.
Yeah, here's an example of a website not using HTTPS. We can literally see what I'm doing on this laptop. And in fact, let me do... What's another type of website that wouldn't have security? That's not a middle school.
Does Craigslist have security?
Is AngelFire still real? Yeah, Craigslist has a ton of security under the hood.
Oh. You just wouldn't know it looking at the website.
Yeah, no, they're actually really good at that. Do you see... Okay, can you see what website I'm on? Oh my god, you can see everything.
Yeah, apparently. It's MKit?
I'm on AngelFire.
HomeKit? Whoa.
Yeah, sorry,
Okay, it's
refreshed
all
it.
just happening so fast.
Oh, they're actually... Are they...
Digicert, pages 03,
Cloudflare.
cloud.tiptop.
You can see everything that this is loading. So in one...
Typography.com, HomeKit. Yeah, there's quite a lot on here, and it's still going. It says invalid syntax, https www.python.org.
I'm going to go to the National Center for Homeopathy, which amazingely does not use security.
Look
at
there's
that.
a GET request right here.
Okay, so you can literally... So Tim is now able to examine exactly what I'm doing. And because this is amazingly... homeopathycenter.org does not use modern security. Weird. We're able to see everything. So if I want to log in, I wonder if we can even see my login attempts. I didn't plan this, but let's try it.
Yeah, I see GET requests. Yeah, see you logged into the user page, or you went to the user page. You GET request homeopathy.org/user. It loaded some icons, some images for the web page.
Okay, I'm about to try to log in. I'm going to click login.
This is a lot. Oh, that looked like it was secure.
Well, what was it? Did you see anything? Log in. Okay, so can you extract my password there? Was it... There it is. My big sick password. Oh my god. So Bettercap just...
Oh, whoa, hey.
Bettercap completely intercepted my login to this website. Can you enlarge that?
Yeah.
Make it even bigger. So I attempted to log into homeopathy.org. So if you guys, homeopathycenter.org. So if you guys want to try this out yourself, just log in with something. And we were able to identify my name as novax@delta.info and my password as my big sick password.
You put an F in there.
Yeah, typos are... How do you pronounce that?
Big F sick password.
Oh, cool.
Oh, but let's say the whole
My
word.
big F sick password. I actually like that better. Okay, cool. It wasn't a typo. All right. But yeah, so you can see that we were able to capture the login attempt in Bettercap. Basically, at this point, we've already penetrated the network. We can see what they're doing. Let's make this even worse.
Oh my god, how can we make it worse?
All right. Well,
we already got your password.
I know. All right, so let's go on your screen. Let's go to a browser window, and let's go to the WayBackMachine. And as a fellow Cat Fancy aficionado, what do you think is the best year?
I'm going to say 2006, 2007.
They were, okay. I felt like they were being a little showy during that year, but we can try it out. Go ahead
if I'm going to be completely honest, I have to admit that I was not on Cat Fancy in 2000.
I don't want to hear this right now. So there's a lot of late bloomers among us. I'm sure that most of us found Cat Fancy late in their lives. But go ahead and just type www.catfancy.com. It's not hard. Could have done that at any point in 2006 or 7, but
okay, well,
here we are.
Sorry.
All right, so let's pick your preferred fake favorite Cat Fancy time. 2006?
Well, everyone loves 2005.
That's what I'm saying. If
what
you were
about
real...
2004? You want to go back to 2004?
The golden years. Well, no, 2005 were the golden years. I would say the 2004 were the classics. A lot of pinups. They did a lot of like fold-outs that year.
Fold-outs?
Yeah.
Oh, in the magazine?
Yeah.
Like it was like a pop-up kind of?
No, you folded it out and it was 3 pages and the cat's lying like that.
Laying out?
Fat as hell.
Oh.
Yeah.
Wow. That's pretty nice, actually.
Yeah. But let's keep it professional. Let's do 2006. They were a lot more conservative that year. So go ahead and pick a web page version. We'll do that one. It'll probably do some redirect and then bring you to the real version. Redirecting you to CatFancy. Look at how secure they are. They have they're just like, we don't want people to find our real URL, so we'll make it CatFancy. Whoa. Wow, from 2006, they sent you a pop-up ad. That's amazing. Okay, well, that's nice.
All right. Okay, so I can close out of this one, right?
Yeah, you can close out of that one. Now, I'm really smart, so here's what we're going to do.
We're going to save the web page?
No. Go to Inspect Source.
Oh, you're just going to do that?
Yeah.
Oh, yeah.
Yeah, right, mouse click Inspect Source. And then click on the top part that has the WayBackMachine. Right up here. Yeah, that. Yeah.
This part?
Delete that.
What?
Delete that element. Just get rid of it. Whoa.
What are you saying?
No. Okay. All right. Close the pop-up and then close right up here. Click that X.
What X?
That X.
That X.
Yeah.
Okay.
I guess that's fine. In mine, I deleted the top element, but now you can save the website.
Yes.
Yeah.
Okay.
Yeah. So now go ahead and save the website. Right mouse click and save. And save it as index.html.
We'll just do it in my documents.
Okay, cool. All right. So now go ahead and go ahead and right mouse click in the terminal window. Yeah. And then split horizontally. Great. So now, in order for us to do DNS spoofing, we have to have something to spoof, and we have to have something to bring them to. So first, we're going to pick catfancy.com. And currently, it doesn't go anywhere because I've stopped serving it. And what you're going to do is pop up a simple Python server in order to start serving this. So the syntax for this is Python 3, TAC-M. And make sure you're also in the right folder, because I think you're in your root folder.
What folder do you... Oh, the same one as mine. Okay.
That index.html is in.
Gotcha.
That's going to be, and this could be our phishing page. We could make this as complicated or as simple as we wanted, but today we're just serving up the classics here.
Python TAC-M?
Python 3.
I have it aliased as Python 3.
That's misleading, but okay. Python 3, TAC-M, http.server, and then space 80. So it's important for us to put this on port 80 because for some reason Bettercap doesn't seem to be able to handle...
I have to sudo it.
Yeah. Bettercap doesn't seem to be able to handle ports. So it defaults to port 80. If we just set it to port 80, then you can give the IP address in Bettercap and everything works out much more nicely.
All right, we've started our Python server.
Cool. So now go ahead and right mouse click inside that window.
This one?
Nope, the other one. And split it vertically.
Oh boy, okay.
Yeah, cool. Now type ifconfig pipe.
Wait, how do I spell ifconfig?
Then pipe grep inet. Cool, and that's your IP address. So 192.168.254.18.
Where
is
18?
Why do you have to... Oh, because you have a wireless card and you... So you're...
I have this and a wireless card.
Which the heck? Okay, try both, because we're going to have to figure out which one it's serving
Okay, the other one's 18, this one's 64. You just remember that.
All right, so go into your browser and test to make sure that we're able to serve this up.
Whoa.
Whoa. 192.168. 168?
That. 18. Let me just go double check. 254.18 and 64.
Yeah, it even does the pop-up. That's great.
It has the pop-up has the this thing though.
That's unfortunate, but I still love that like CatFancy gets you with it. Can I see the content just once? I don't know what this... Oh, look at that. I'm sorry. I love this issue. I have it. Okay. Anyway, let's... so that's great. That's very exciting. And if you go back to your terminal window, you should see that you got a hit. Look at that. All that jumble on the left side.
Right here?
Yeah, so you got to hit.
So we created a server that's hosting from the folder with the index.h. And since it's called index.h, that's going to be the HTML file that it serves.
Exactly,
Gotcha.
exactly. Okay, so now it's time for us to do the actual DNS spoofing. And now go ahead and to show that we're not lying, try to go to catfancy.com.
Mm-hmm. Okay.
Or if you want to pick a different domain that doesn't exist, you can do that too.
I mean, CatFancy is perfect. Oh, it's your.
I'm still serving it?
You're still serving
Really?
your one. Yeah.
Oh, wait. Oh, am I? Yeah, I am. Go ahead and refresh it. I'm so sorry. I'm so sorry, everyone. It's not the issue of CatFancy we meant to serve. All right. So now it's not going anywhere. Am I still? I must be DNS spoofing too. I thought I stopped. That's very funny. I stopped running Bettercap, but it hasn't stopped working totally. All right, well, this is going to be interesting. I guess what that means is, can you, what I think has happened is that the ARP cache hasn't reset. So what that means is that your computer still thinks that my computer is the center of the universe. In a terminal window, type ARP-A. Whoa, there's so much stuff going on. All right, so we basically need to find, wow, there's so...
Should I grab some of it?
There's just a lot going on here. So there's like lots of network paths going on. We can see that it looks like, yeah, there is some ARP spoofing still going on.
How do I clear my network cache?
You
or
ARP
whatever?
spoof harder. All right, okay. So you just have to take control. All right, are you ready?
Sure.
Yeah, in Bettercap, let's now take control, and we're going to run our spoofing command, which is set space dns.spoof.domains. Did you just press enter?
No.
Okay, good.
That was a space bar.
Oh, you just pressed it so hard. All right, dns.spoof.domain, domains with an S, space, and then catfancy.com or catfancy.info, whatever you want. And then call semicolon, space, set dns.spoof.address.
Spoof.
Then that's going to be your IP address, so the .64.
Space?
Yep, space. So that's going to serve up our fake page, and then semicolon, and then dns.spoof, space, on. And this should do everything we need to start the DNS spoofing. Let's try it. Okay, so catfancy.com is now supposedly
being redirected to the local IP of 192.168.
I'm very nervous. All right, let's switch over to my screen and see what we can do. So I'm going to try going, I'm just going to open a new screen. I'm going to go to... And it might have cached... No! Hey, it worked! Okay, so you've taken back control of the network. And if you look over there...
Whoa, I just got
if we switch back on Tim's screen, we can see tons of stuff is happening. We've got a hit on the server. So we can see that someone is now in here sniffing around our CatFancy page.
All of these you trying to go to CatFancy.
Yeah, I'm desperate to get in. There's a lot going on here and I have to know. Like, look at this butterball. Like, what's going on with this?
You didn't get the pop-up, though.
I know. Yeah, I have an ad blocker. You can see it tried. Nice try.
Oh, okay, cool.
Yeah. So this has been a pretty simple way of being able to just create a website from any other website. I think that's everything we're doing today.
Mm-hmm. That was a lot.
Surprisingly fast to be able to do this, but we also did a bunch of bad stuff because unbeknownst to us, we also were able to intercept a login request on a website. And if we were trying to do something like log into the router, typically routers and IoT devices do not have any sort of protection like that. So if you're logging into your router and someone on your network has Bettercap running, it probably means they can see all of those logins. And that is a very bad thing because then they could go in and administer everything themselves. So all they really need is to be connected via Ethernet or to have the Wi-Fi password, and they're able to see this information.
So to protect yourself against this attack, don't let people into your network that you don't know, and always go to websites that are secure.
Yes.
HTTPS?
HTTPS, and also if I was using a VPN, none of this would matter.
Oh, really?
Yes. So if I'm using a VPN, basically everything I'm doing, including my DNS request, is encrypted and sent in a tunnel all the way over to PIA or whoever we're using. And then listening like you are, even if I were to visit this insecure website, you still locally, by spying on my Wi-Fi, wouldn't be able to see what I was doing. And you certainly wouldn't be able to see my logins or the DNS requests that from the websites I was going to. So now, as you saw, I can go anywhere I go that's not secure. You can see exactly what I'm doing. And anywhere I go that is secure, you can still see the DNS requests that are calling all that information up for me. So that I don't have a lot of privacy really without a VPN, because you can still snoop on either like where I'm going or actually the contents of what I'm doing in logins.
All right, cool. So HTTPS, don't let people on your network that you don't know, and VPN.
Yes, I would say a VPN is definitely a good idea. It makes sure that this kind of information is encrypted end to end. And while you won't be able to VPN encrypt your connection to your router, you still can encrypt it to other websites you're visiting that might not be secure. And again, it is important to make sure that you limit how many people have physical access to your network or who know the password. You can also do things like segmenting your network so that people can't scan around freely or basically access different IP ranges that they're not trusted to. So if you go to like a Starbucks or something, generally a lot of these attacks just won't work. And that's because they organize their networks in a different way that basically gives every person their own subnet. So this
.254, the last, that's the subnet, right?
Yeah, you can split a subnet that way.
Okay.
Yep. So if you are splitting a subnet and you have people basically isolated to their own portion of the subnet, it means that they can only kind of like run amok within that portion of the subnet. At least as far as what we're talking about here. There's other ways of escalating that we could go into another time. But generally, if someone's in your network and it's segmented correctly, then if you're providing like a public service of a Wi-Fi network, then they'll only be able to affect, maybe they'll be able to try to log into the router or something, although you can disable this, but they won't be able to try to ping other people's devices or serve them fake web pages. It just won't work because they're not actually on the same network. Pretty handy. And it's just a little IT trick that like people that haven't done network administration may not know about, but it's the difference between being able to go to a public Wi-Fi network and scan and see every single device that's on the network, as well as like get which ports are open and what stuff they're running. And when you run a scan and there's just nothing. I mean, try doing a free scan like Fing or something like that the next time you're at a restaurant or coffee shop that has free Wi-Fi, although it might be a while with how things are going. And you'll probably notice that either you see everything on the network or nothing on the network. And that's generally how those sorts of businesses go. They either have good security that locks it down so that you can't do stuff like what we're doing today, or they have bad security that leaves everything wide open and you can see them log into the security camera and boom, you have access. So
that's sketchy.
Yeah, very sketchy. Cool. Well, I have to say a big shout out to Bettercap. Everything worked flawlessly today, and that's a rare and difficult thing for a Wi-Fi or even Ethernet tool. So the fact that it works out really well when we're practicing this is pretty incredible.
It was a very painless experience.
Yeah. So if you're a beginner and you're looking to get into the sort of network stuff, Bettercap has Bluetooth stuff that's very interesting. It also has a lot of Wi-Fi modules that are very interesting. It was one of the first to be able to capture Wi-Fi handshakes from devices that from networks that don't have anything connected, which is really cool because usually you have to kick a device off a network to get a handshake. Thanks to a bunch of advancements in the hacking community and Bettercap taking the time and energy to easily implement this, even a beginner can now go after a network that has nobody attached and break in. So that, I think, is pretty revolutionary and is just kind of forcing the hands of the people who are in charge of coming up with Wi-Fi security to do a better job because this stuff is easy. Cool.
Yeah.
Well, if you like this, you should definitely check out all the rest of our content on SecurityFWD. We do these twice a week and we save all the streams. So if you're just joining us and you missed this, you can immediately watch it as soon as it's up on the YouTube channel. You'll be able to check it out there, subscribe to upcoming events, and also be notified as soon as we go live. I'll have Tim and other guests showing off more great tools as we go on. And I think we're also going to do more stuff on PowerShell. I know our last little PowerShell adventure was very popular, so we'll probably be getting back to some of that later as well.
Yes, I think our next live stream should be PowerShell.
Cool.
Correct? Yes.
Cool. So, all right. Also, big shout out to Varonis for making sure we can continue to do this. If what we scared you with today motivates you in any way to take your company's security seriously, you should probably try out a demo and at least take a look at how they can detect attacks like this before they become more serious. With everybody working from home nowadays, big companies rely on solutions like Varonis to make sure that once hackers get in, they get detected quickly and can't do much damage. So if you're in the market for stopping people like us from getting into your employees' VPN and doing all sorts of bad stuff with Active Directory, you should probably give them a call. All right. I think that that's all we got today. We'll see you guys next time. Thank you so much for joining us, and we'll see you next time. Bye.
Bye, guys.